So today I want us to look at integration questions. This is in P3 mathematics. So we'll look at integration questions, and I just want to say thank you to Save My Exams, because that's where I get the questions that I normally get to use for revision with with you guys. So Save My Exams, that's why I get this, and I will be going through most of the questions for easy, medium, hard, and very hard. So for this first part, I'll just quickly run through a few questions from the easy part. What I just want to start with is actually saying integration is just the opposite of differentiation. So let's just quickly dive into this. I'll be giving you some rules, integration rules where necessary, but on some of these I'll just be trying to do the opposite of differentiation. Yeah, and then for more detailed notes, you can get in touch and just I'll send you everything. So for this one, this is just exam preparation where we just run through basics and minus really going deep into the topic. Yeah, so here we are given to integrate 1 over x dx. So now what I want to do is I'll be doing some, let's say for example, you've got f of x equals to ln x. What we know is that if you differentiate to get f prime of x, you get 1 over x, where x is not equal to 0. So in this case now, is that what we are given to reverse is 1 over x. So this is just going to give us ln x. You can put modulus there to indicate that this cannot be negative, plus some constant c. So this is the derivative of this function here. So that's your answer, because we are just trying to reverse what was differentiated, in other words. And then here we've got use calculus to evaluate this. So in order for you to understand integration, you must be somehow good at differentiation. Otherwise, it would be more like shooting in the air. So what we know, this is an exponential function, is that if you've got f of x equals to e to the power of x, f prime of x is simply e to the power of x. Now e to the power of x to be reversed to what was differentiated is simply just going to be equal to e to the power of x, and then in this case we are given limits to substitute. The lower limit is 0 and the upper is 1. So this is more like we are finding the area under that curve. So what we're going to do here now is just to substitute. Where there is x, we are going to have e1 and then minus e to the power of 0, which then gives us e minus 1, because anything raised to power 0 is actually 1. Okay, find an expression for y given that y is equal to the integral of 3 cos theta d theta. Okay, so now again here what we are being asked is to integrate this, but in our MFP formula sheet we know that if you've got f of x to get your sin x, if you integrate this to get f prime of x, you get cos x. Okay, so the fact that we know all these things from differentiation, we are just trying to reverse this. So y in this case is this going to be equal to 3 sin theta plus c, which is some constant. So the answer to this is just that. Now you must also know that when it's indefinite integral, we add some constant c to stand for numbers or constants that were lost when we differentiated, because we know that if you differentiate a constant you get 0. So when we add the c, we're putting into recognition that there could have been some constant that was differentiated and lost in the way. So now, but when we have limits, these are now definite integrals, because we had been told nothing was lost there. So very important to take note of that. So this was question number 1. And then the key thing on integration is actually knowing that it is the opposite of differentiation. So if you know your differentiation very well, you should be enjoying integration as well. So let's look at another question and see. Now on the medium section, I've found this question here, and like I said, differentiation is basically just, integration is just the opposite of differentiation. If you look at this question, you may think this is a very complicated question, but let's look at maybe if this was, if you have 2x plus 4, maybe for some, then you've got power 2, and you are said this is f of x. And then you are asked to differentiate this to find f prime of x. What we know using composite functions is that you have to multiply the power. So you do 2. Okay, remember we are multiplying. So to integrate, you have to do the opposite. 2 times the derivative of the inside, which is 2. Then you maintain this function here, and you subtract 2 minus 1. So the idea is here, I multiplied by the power, and I also multiplied the function by the derivative of the inside. So now when we come to integration, remember we've also subtracted 1 here. I'll leave it like that. We must add, then divide by the answer we get here, and again divide by the derivative of inside. So with that understanding, then the integral of this should be very easy. So what you just need to do here is that you're going to do this. You keep your 8 as it is, and then we've got 2x minus 1, okay, to the power of 3. So I'm going to add this plus 1. Then I'm dividing by that answer, which is 4, times, again, I'm going to divide by what I multiplied by, which is the derivative of the inside 2. If you look at this now, you are going to have 8, in open brackets, 2x minus 1 to the power of 4, okay, over 8, which these can divide to give you the integral of this as 2x minus 1 power 4 plus some constant c. So that's our answer for the question. So it's really just basic reverse of differentiation, but for you to be able to do this, you must somehow have some depth on your differentiation. So you can actually confirm that if I was to differentiate 2x minus 1 to the power of 4, I'm going to get 4 times this function is 4 times the derivative of the inside, which is the chain rule, and then I get 2x minus 1 to the power of 3, which gives me 2x minus 1 to the power of 3, which is what we were asked to integrate. So it's very important to be quite good with differentiation. And if you need a video on differentiation, please feel free to let me know, and I will make one for you. So let's now look at this question here. Again, the purpose of this video is to revise with you basics of differentiation so that you can see their importance on integration. Now, what we know, let's say you've been given f of x equals cos 2x. What we know is that in this situation, you are going to have, since the derivative of cos is negative sine, okay, in this case negative 2x, times the derivative of the function here itself, which is 2. So this would then become 2, negative 2, then sin 2x, okay. This is what we would get when we differentiate the cos function. Now remember, this is when we differentiate cos 2x. There is that negative 2 that comes there, okay. Now in this case now, what would give us negative sine okay, when we differentiate, is not cos but negative cos, since the derivative of f prime of x for cos is negative sin x. Okay, now it simply means if you have f of x equals to negative cos x, what you are going to get is f prime of x being equal to negative sin x. Okay, or positive sin x, sorry. So now if you look at these questions here and that understanding, differentiating this shouldn't be a problem. So we know that initially if we have a double angle cos, we are going to have the derivative of the inside. So this should basically just be, okay, negative 1 over 2 cos 2x plus some constant. No, here we're not going to have a constant. Okay, we're not going to have a constant because we've been asked to find the definite integral. Why am I having negative cos? Okay, negative cos. It's because if I differentiate cos 2x, I get negative 2 sin 2x. Okay, so which means to kill these 2 here, I have to have half of negative cos, because otherwise it would have been 2 here, but there is no 2 there. So these are basic differential understanding. Now here, what we have now is the limit of 0 and pi, quarter pi. So what we just want to do now is to find this area. So what we're going to do now here is just to do negative half and then cos quarter pi minus half minus negative half. Okay, I'll put that in brackets, cos 0, because 2 times x would give us 0. So now if we do this, we should actually know what cos of 45 is. Okay, so we want to know what we are doing here, which is going to give us, so this is going to give us negative root of 2 over 2. Then cos of 0, we know that that is 1. Okay, you can say, just say that is 1, but then plus here, so we're going to have a 1 here times half, so plus 1 over 2. Now this we can actually factorize to get half and 1 minus root of 2 as our area, just that they didn't ask for the area. So that's a very good understanding here. So what I want to emphasize on is that for you to be good at integration, you must have time to look at your differentiation. So I don't want to give rules of integration, because sometimes they run away from the fact that you need to know your differentiation. So I'll just go through these questions working from differentiation to integration and vice versa, so that you can see the connection between the two. Otherwise, all of these have rules. Like for example, what we know is that if you've got sin of f of x, okay, you want to integrate this. Okay, what you are going to have is 1 over f prime of f of x, okay, negative, then cos f of x. These are all rules, but surely they are meant to just simplify your life. If you understand basic differentiation, you will be able to see them. So all these rules exist, but we don't really need to know what they stand for. We just need to revise things. So let's look at some more other examples here. There is this other question here which says find an expression for this. Again, here, if you want rules, there are those of you who may want rules. What we know is that if you've got integral of e f of x, okay, dx, the rule is simple. You're going to have 1 over f prime, which is the derivative of f of x, over e f of x plus some constant c. So going by this should actually mean if we want to, now here we've been told that that's dy dx, so they want us to find y, meaning they want us to find the integral of this function. So what we are doing is basically doing the integral of 3e 3x. Now if you think about this, there's a constant that we need to pull out, and I'm just going to pull that constant out now. So we're going to have, we've got 3e 3x dx. I will write this as 3 integral e 3x dx. Now going by this formula, I have to find the derivative of the function of x, this one. So this simply means I'm going to have 3 multiplying 1 over the derivative of f of x, which is 3 here, and then I've got e 3x, which simply means the derivative of that is that, and that would divide to leave me with e 3x plus some constant c, since we are dealing with indefinite integral. So you can see that there are rules to these things, but I don't really like giving the rules so you don't see the connection between differentiation and that, because truth be told, if you were to differentiate this guy, you would have got, you know, just what we are getting back to. So very important to know your differentiation before you look at integration. Let's look at another question and see if we can get more challenging questions on the easy part. Okay, then I found question number 4. I think this is one of the good questions that I think we can go through here. We are told that given that u is that, show that du is equal to 3 dx. Du means the derivative of u. So what we know is that du dx, okay, is equal to the derivative of this 3. And then we want to make u the subject. We can multiply by dx and then multiply this side by dx, so that these can cancel out to give us du being equal to 3 du, like that. Sorry, so okay, so now I found question number 4 here. We are told that u is equal to 3x plus 2. Show that du is that. So what we are just going to do here, we know that du means the derivative of u in terms of x. So we know that du dx is equal to the derivative of 3x is simply 3, and then we are going to multiply this by dx and multiply this side by dx, since we are trying to make du the subject, to then get du as being equal to 3 dx. So this means hence shown. So we've shown what they wanted us to show, just like that. So that's the mark for that one. Now remember, they now say find the integral of 3 cos 3x plus u dx. Now this one I like, because it's what we call integration by substitution, but I'm not going to go into details of what integration by substitution is. I just want to solve this question using algebra. Since we've been told that u is this, it means what we're going to have, if you just look at it, is 3 cos u and then dx. This does not make sense, because we've got a function of u being differentiated in terms of x. So we must find a way of dealing with dx. Okay, so I'm going to say this is not making sense, because what we have is 3 integral cos u dx. This is not sensible, because you cannot integrate a function of u in terms of x, because you do not have x. I love that. So now what we need to do first is to do this. Since we've been told that u is equal to 3x plus 2, okay, we are going to find the derivative of the u function So we've got du dx being equal to 3, okay? Now remember, this dx is the abnormality that we've got here, and it's the one we are trying to sort out. We must make it subject of the formula. So what we know is we'll cross multiply here and say du is equal to 3 dx, and then we want to divide by 3. We want to divide by 3 so that dx can be equal to du over 3. Now it means wherever there is x, dx in our integral here, we are going to put du over 3. That will make us cancel something. All right. So now if you think about that now, instead of having dx here, okay, we are going to have the integral of 3 cos u, okay, times dx is actually du over 3. So we are going to have du over 3. And if we do that, that 3 and that 3 is going to cancel, which leaves us with integral of cos u du, which is what they are asking us to show. Very nice mathematics. When what we've been given is that this is just the confusion that we needed to sort out. You cannot have an integral of a u function in terms of x. It doesn't make sense. So we have to find a way of killing dx. And the way we killed it is to differentiate the u function in terms of x and make dx the subject. And then replace where there is dx, we put du over 3 so that we can cancel out the dx. Then they are saying hence find. Now hence means with what you've done, okay, can you now find the integral of this? So now remember, we've already shown in terms of u that this is integral of cos u du, okay? So what we just need to know now, what's the integral of cos u? You know that if you've got f of x, for example, equals to sin x, okay, then f prime of x is equal to cos x. This is a well-known fact. So meaning if you are given to integrate cos x, you must actually go back to sin x. So here, cos u is just going to be equal to sin u plus some constant c. This is the integral of that, because we already know that this takes us to there. That's where we are coming from. So this is the answer. Now if you want to write to replace your u, since your u is 3x plus 2, you can say this is sin 3x plus 2 plus some constant c. This is the derivative. So like I said, integration is basically the opposite of differentiation, and to enjoy integration you must be good at differentiation. Okay, so let's look at another question and see if there's anything nice here. Okay, so I'm going to solve this one last question on the easy part. Since we've been given that the identity of the double angle cos 2a is equivalent to 1 minus 2 sine squared, show that sine squared is equal to that. So basically for this one, you are just being asked to make sine squared the subject of the formula. So what we know, I'll first start by writing the left hand side and say 1 minus 2 sine squared a is equal to cos 2a. Now in this case, I'm going to transpose these. Okay, so I will transpose the sine and then the cos 2a. So if I transpose that, I'm going to have 1 minus cos 2a equals to 2 sine squared a. Okay, if we do this, I just want to make sine squared the subject. So normally I will just rewrite this to, I'll divide by 2 here and divide by 2 here. That would mean that and that is going to divide to give me sine squared here. So it would mean, therefore, that sine squared a is simply equal to, you see these 2 here, This is more like half. I can put this one already. First, we can say this is cos 2a over 2. Okay. Now we can pull out this half and just say sine squared a is simply equal to half, then leaving 1 minus cos 2a, hence shown. So we've shown that this is what they wanted us to show. And then look at the second part. They are saying hence, meaning with the answer that we found here, which is this one, can we then differentiate what sine squared x is, of which we already know that sine squared a, if we want, we can put x there, is equal to that. So this integral here should not give us problems, because now we are going to have the integral of, where there is sine squared, I'm going to put half, open brackets, 1 minus cos 2x. So I'm dealing with this integral here, 1 minus cos 2x, and then dx. Okay, and then we're evaluating this over the integral of pi, half pi, and pi. A very good thing. So what we just need to do here, if you want, you can do this in two different ways. You can decide to expand the half here to mean you are integrating the half, okay, and then the minus, so half dx minus the integral of cos 2, so there is half here, so another half here, cos 2x dx, if you choose to go that way. Again, this, like I said, this is just one way in which we can distribute the half and then integrate these independently. So the integral of half, obviously, is just half x. Okay, we already know this. And then the integral of this, remember, we've got cos. So what differentiates to give us cos is sine 2x. But then there is that guy there, and you remember the rule that I told you. If you've got the integral of cos of f of x dx, this is simply the same as negative 1 f prime of x. Okay, the integral, sorry, not f prime of x, this is simply going to be 1 over f prime of x sin f of x. These are the rules. So now here already we know the f prime, 1 over f prime, so we are going to have minus 1 over 2, okay, since that's just a constant, times 1 over 2, which is the derivative of the f of x here, then sin 2x. Now all of these must be evaluated under the limit of half pi and pi. Okay, so we can then simplify this. Is negative half times half gives us a quarter. So it's like we are dealing with half x minus 1 over 4 sin 2x. And all we are doing now here is evaluate these lower boundaries here and see what we are going to get. So this is more like we are finding the area that is bounded by this curve of sine squared x. So if we put pi there, we put pi there. So now here what we are just doing is substitute these limits. So we are going to have a situation where we've got half pi minus, okay, 1 over 4 sin 2 pi. Okay, then this subtracting half dot half pi minus 1 over 4 sin, when I put where there is x, I put half pi. I'm going to have pi here because that's a simple algebra where we do 2 times pi half. That is going to cancel to give us pi. So we know that this is going to give us 0 because sin of 360 is 0. So we've got half pi here and then we know that this gives us a quarter pi, so we've got minus a quarter pi like that, and then negative, we know that sine 90 is 1, sin 180 is actually 0 again, so that will just go to 0. So this is what we just have here. So we can multiply this by 2, multiply this by 2 to have 4 over to have, just hold on, I'm not using a calculator, so let's see what we're going to have here. So what we are going to have now in this case is simply 2 over 4 pi minus a quarter pi, which should give us the answer as 1/4. This should just give us 1/4 as our answer for that question, which is this one here. Just a lot of writing in one space. So quite some scruffy writing there, but we are basically just doing substitution. So this is maybe let me do another question here and see if there's anything nicer we can look at to use substitution. Maybe let me do this as the last question. They are saying use substitution to find the integral of that. Again here, if you remember, if I put u where there's 4x, I'm going to have the integral of 4u to the power of half, again then dx. This, if you remember from where we are coming from, is an anomaly. We cannot be integrating a function of u in terms of x. We need to find a way of getting rid of dx. The only way we can do that is first to do du dx of this given substitution, which gives us 4. Then we make dx the subject of the formula in terms of du, so that we can replace it where there is x. That's how it goes. You only do that if you do that over 1 to get your du being equal to 4 dx. Now if you look at this, we want to make dx a subject. We divide by 4. We divide by 4, which means that dx is equal to du over 4. Okay. Now if we do this, then where there is dx, I'm going to put du over 4, so that the function, the integral, can be in terms of u, and it's a u function. So that would then imply we are integrating 4 u to the power of half times du over 4, and then the 4's can cancel out to mean, in other words, we are integrating u to the power of half du. And then to integrate this, it's more like you just have a function of x. They just say integrate x to the power of half. So what I'm going to do now is to just come over here. We are integrating the u power half du. So to do this, this is just a normal function. We are going to add plus 1 and divide the answer that we get. So this is just going to be equal to u half plus 1 over half plus 1. And then this would be evaluated over the lower and the upper limits of 2 and 6. So what we know is that we are going to get u 3 over 2 over 3 over 2. Now in mathematics, this should not give us a problem, because we know how this is going to be. If you divide 1 over a fraction, it's more like you're just reciprocating that fraction. So what we're going to have now, this is the same as 2 u to the power of 3 over 2 over 3. Then this is over the limits 2 and 6. So what we're just going to do now is to substitute these limits and see what we are going to get. So if you do your substitution, you are going to get this answer as being equal to 2 over 3. Your u, Now in this case, before we go anywhere, okay, before we go anywhere with these limits, guys, sorry, that was my mistake on the limits. Remember that the u function is given as 4x plus 1. So to find the upper limit, we must convert these and write them in terms of u. So the upper limit for u now would be 4 times 6 plus 1, which gives us 25, isn't it? The upper limit is 25. So this would be 25. And then we must change the lower limit as well according to the u that we have. We have u equals 4 times, where is the upper limit, times 2 plus 1, which should give us u equals 9. So the lower limit is 9. So now to find now the integral here in terms of u, we are just simply doing the square root of, if you follow, if you want, just punch this on your calculator, the square root of 25 to the power of 3 over 3 here minus 2 over 3 square root of 9 to the power of 3. So we know that 5 times 5, just punch these limits on your calculator if you want. Just put 25 there, punch on your calculator, it will work. I'm just trying to use indices because I'm limited with calculator usage here. So that is 5 times 5, 125. So you can say 5 root that times 2 divided by 3. You find that this gives you 250 over 3 minus, this is 3 cubed is 27. 27 divided by 3 gives you 9. So 3 cubed, then divided by 3, then times 2, find 18 minus 18. So then we can say the whole lot of this gives us the answer as 196 over 3. So this is the answer that they wanted. The only mistake I wanted to make, I almost forgot to substitute. These limits must also be converted to u limits by substituting the upper limit into the given substitution formula and the lower limit to find these ones. Sometimes we make that mistake of not converting the limits. So it's important we convert the limits. So these are some of the good questions I found on the medium part. So please watch out for when we do the hard part, the medium parts. This is easy questions. I think on the Save My Exam, I picked the easy part, yes. So part 2 is going to be when we do the medium questions. So watch out for part 2. These are some of just the other questions on the easy part. And I'm sure part 2 is going to first just finish the easy parts as well. So thank you very much for your time.